Okay, let's go talk about the intake manifold. The intake manifold in a car is the part of the engine that distributes the airflow between the cylinders. Okay? Okay, let's see the manifold, GT Power application, and then I explain that to you. Here we have 4 cylinders engine, and this red circle is manifold, intake manifold actually, as you can see in this picture. Okay, as I said, the intake manifold is a component of an engine that distributes incoming air evenly to each cylinder, so combustion happens efficiently. It's designed strongly affects power, fuel economy, and engine response. Main parts of an intake manifold, as you can see in this picture. Number 1 is Plenum, the main chamber where air first enters. It acts like a reservoir that supplies air to all cylinders, okay? And about runners, tubes that carry air from the plenum to each cylinder. Their length and diameter affect performance, okay? Long runners. As I wrote here, long runners is for better low RPM torque, and short runners better for high RPM power. Actually, for better torque in low speed and better power in high speed. Okay. And about throttle body, mounted before the manifold, it controls how much air enters the engine. Sensors and ports such as map sensor, vacuum ports, temperature sensors, okay? So, about fuel injector, as you can see in this picture, where to install the injector? The injector location depends on the fuel injection system type. Most common place to install the injector is port injection. The injector is mounted on the runner near the intake valve so that fuel mixes well with air, fuel doesn't stick to walls, and throttle response improves. And best position angle toward the back of the intake valve. And the older design is throttle body injection. Injector sits before the manifold. Fuel or air mixture splits inside the plenum, less precise than port injection. And in modern engines, we have direct injection. Injector is not on the manifold. It sprays fuel directly into the combustion chamber. And for summary, if you want the optimal injector placement on an intake manifold, mount it on the runner close to the intake valve, aimed at the valve for best optimization and efficiency. Okay, let's go to the GT Power app. As I said, this is 4 cylinders engine. This part, as you can see in this picture, are cylinders, pre-chamber, and crank angle. Crankshaft, turbochargers, an EGR system, and absolutely throttle. And ECU. So we just want to go through the manifold, intake manifold in this session, and I will explain the other parts in other sessions. Okay, so how we can design intake manifold in Duty Power. Let's go. Intake manifold consists of pipe round and flow split. So let's go. Here we have flow split. Okay. We should fill in these blank places. And here we have pipe round. Actually here we need 3 pipe round, as you can see in this picture. Here we have 2 pipe round because we have 2 valve, intake valve. Here you can see we have 2 intake valve, so we need 2 ports for manifold. Let's see the details. You can click on right click actually in each part and go to the help. Where is help? Show help. Okay. Pipe round. This pipe is used to model pipes that have a round cross section and an optional bend. This is a round pipe with bend actually. Data entered to describe the bend will be used to automatically calculate the pressure loss coefficients that account for the associated head losses. So you can see we had diameter at inlet end. Okay, this is inside diameter at the inlet, port 1, or the name of a dependency reference object. Inside diameter, and diameter at outlet end. This is inside diameter at the outlet. Let's see. Here we have diameter at inlet end and diameter at outlet end. This is inside diameter. Okay. And legs. So let's go again to the help. Okay, here we have length, pipe length, or the name of a dependency reference object. Okay. Discretization lengths, into which the pipe will be subdivided for code calculations. Okay, and in the same way we can see the help file for material, for angle, radius, and the other features. Wall temperature, heat transfer coefficient, friction, and absolutely you can see here formulas. Yeah, and I can at this point that the discretization length is 4/10 of the cylinder diameter at the inlet and 55/100 of the cylinder diameter at the outlet. Let's go to flow split, right click on that. So this object is used to describe a flow split volume connected to one or more flow components. Okay, you can define that at XY table, XY function, and you should describe surface area, material, thermal features, and so on. You can see the features here, main features, thermal, pressure drop, boundary data. All of these features are explained in the help file. Okay, in this model I entered the numbers according to the real engine specifications, like this. And inlet and outlet is condition and environment, thermal, pressure drop is default, is as default, okay. And this is flow speed, wall temperature is 300 Kelvin. And about boundary data, this boundary data are determined according to the number of connected ports.